Hi everyone, in this lesson we're going to learn how to find area when we have our shape plotted on the coordinate plane. So what I'd like you to do first is go ahead and plot all of the shapes that are given to you on your graphs on the outside and the four that are on the inside, and then when you come back I'll show you what to do. So plot your points. Okay, so when we have shapes on the coordinate plane, there's a couple different methods that we can use to find their area. So for this first example, it says to find the area and the perimeter. We'll start by finding the area because that one's a little bit easier for this shape. So remember the area formula for a triangle is 1/2 base times height. So when our shape is positioned like this, it's really easier than the other kind that we're going to do because you can count what your base and your height is. So if we count this length, we get 6. So our base is 6, and then remember your height is always perpendicular. So this line right here would be our height, so then our height is 3. So we just have to plug that in. So 1/2 times 6 times 3. So we get that our area is 9 units squared. So area can be as simple as that, just counting how many boxes, how big your shape is, and plugging in the numbers. Or it can be complicated like the other examples we're going to do. Okay, so let's look at our perimeter. Well, we know that this side is 6, but the other two sides are a little bit harder to find because they're not horizontal or vertical, so that we can't just count the boxes. So that's where the distance formula comes in that we learned last lesson. So we need to find the distance between EL and FL using the distance formula, and then we'll be able to add up all of our sides to find the perimeter. Okay, so we need to find the length of each side. So let's start with EL. So we'll use the distance formula between these 2 points to find the length of that line. So remember the distance formula is you subtract the x coordinates, square them, and then subtract the y coordinates and square them, and then we add those answers together. So our x coordinates are -2 and 2. So 2 minus -2. So we did the second one minus the first one. And then the y is 4 minus 1. Okay, so remember that minus negative is plus, so we would have the square root of 4 squared plus 3 squared. So that would equal the square root of 25, so we get 5. So that means that the length of EL is 5. So now we need LF, and then we can add all of those up to get the perimeter. Okay, so LF, our x coordinates for L and F, so 4 minus 2 squared plus 1 minus 4 squared. So we have 2 squared plus -3 squared equals 4 plus 9, which is equal to the square root of 13. So that means that this length here is the square root of 13. So to find the perimeter, we just add up all those sides. So 6 plus 5 plus the square root of 13. So that'd be 11 plus the square root of 13. And we can type that in our calculator to get an approximate value. So this is approximately equal to 14.61 units. So how I got that was just typing it in our calculator. Oh, you can't see. So the square root of 13 plus 11. Okay, good. So let's try some more complicated examples. So if we take a look at this triangle that we have here, triangle DOG, none of our base or height are horizontal or vertical, so we can't just count them. So when we have shapes like this, we have to kind of manipulate it a little bit to be able to figure it out. So what we're going to do is draw a box around our triangle. so that it touches all of the vertices. Okay, so this is kind of like when we found the shaded area. Okay, if we consider this our shaded area, if we find the area of the whole thing and then subtract those other triangles, we'll have just the shaded part. Okay, so that's what we're going to do. So to help keep this, keep track of everything, I'm going to label our triangles. So this will be triangle 1, triangle 2, and triangle 3. So the first thing we need to do is find the area of the whole entire rectangle that we created. So the area of the box, and if we count the length and the width, they're 5 by 6. So 5 and 6. So the area of the whole box is 30. So now we need to find the area of each of those triangles, and then we'll subtract it from the area of the whole thing to get that shaded triangle that we wanted. So the area of triangle 1 would be 1/2 base times height. So these two sides are going to be perpendicular, so it doesn't matter which one you call base or height. You just need the two sides that are perpendicular. So this side is 2, this side is 1, 2, 3, 4. So this would be 2 times 4. So half of 2 is 1, 1 times 4 is 4. So the area of triangle 1 is just 4. So now we'll do the same thing for triangle 2 and triangle 3. And since they're triangles, we'll use the 1/2 base times height formula. Okay, so triangle 2 is 3 by 6. So 1/2 times 3 times 6. So 3 times 6 is 18, and half of 18 is 9. For triangle 3, we have 2 times 5, which is 5. Okay, so we found the area of the whole box. We found the area of those 3 triangles that are not included in the triangle that we want. So now we just subtract those areas from the area of the whole box. So the area of triangle DOG would equal 30 minus this. So 4 plus 5 is 9. So if we add those all together, we get 9 plus 9 is 18. So minus 18, so it equals 12. So the triangle that they had told us to find is 12 units squared. So the method here again is to draw a rectangle or a box around the shape that you're trying to find the area of and break it into pieces, because we can find the area of those pieces and then subtract it from the area of the whole thing. Okay, so let's try. I'll help you get this one set up and then you can finish it on your own. So with these, you have to be very careful about how you draw your lines and make sure like what you're counting and stuff, because you don't want to, like here, you don't want to stop and count that this triangle only goes to here, because it actually goes to that vertex there. Since this one is so close to that line, that could happen here too. So you just have to be careful when you're counting. Okay, so go ahead and draw a box around your quadrilateral life, and then we will break it up into pieces and find the area of each piece. Okay, so when we're doing shapes that are bigger than triangles, sometimes this might happen where your box doesn't actually touch all your vertices like it did here. So there's a couple different ways that you can handle this problem. You can split it up like that, and then you'd have 5 pieces, and making a square and then those 2 triangles, because it's easy to find base times height if you make those right triangles. Or you could split it up like this and make 2 triangles there. For those, you just have to remember that the height would be perpendicular, like what we did on the front. Okay, so that's how I'm going to do it, so it's less things that we have to find. Okay, so I'm going to label, and it really doesn't matter how you label it. Sometimes I go around to the right, and sometimes I go to the left like I did for the first one. It doesn't matter. For this, just make sure you label it the same as mine, but when you're doing them on your own, you can label them however you want. Okay, so we need to find the area of the whole box and the area of those 4 triangles. Okay, so go ahead and try to find those areas, and when you come back we will go over the answers. Okay, so the area of our whole box was 56 because we have 7 times 8. The area of triangle 1 was 6, triangle 2 was also 6, triangle 3 is 7, and triangle 4, we got 4 for this triangle down here. So then when we subtract the sum of those from 56, we get that it's 33 units squared. Okay, so for the trapezoid up at the top, this one is kind of like the triangle on the front. You don't have to break it up into pieces because you can see the base and height the way it's drawn because the lines are horizontal. So we can use our area formula without having to draw the box around it. So just remember that if it's horizontal, like if it's orientated horizontally and it's a shape that you have the formula for it, you don't have to do all the extra stuff that we did in those last 2 examples. Okay, so we just need to find our height and our 2 bases, and then we would be good to go. So remember, height is always perpendicular, so this or any of those vertical lines could be your height because it's perpendicular. So the length of that line is 6 if we count those boxes. So our height is 6. Now we need our 2 bases. So if we count up here, we get 5. And then the bottom length is 12. So plugging in those numbers. So half of 6 is 3. 5 plus 12 is 17. So 3 times 17 is 51 units squared. Okay, so let's take a look at our last example. So this one ended up with 5 vertices. So that means when you break up your triangles, you're going to have 5. If you do it like what we did over here, or you can do the square thing, it's going to happen over here because that vertice is not going to touch your box that you draw. So go ahead and draw your box, and then label your triangles, or however you want to label them, and then find the area. So pause your video and try to find the area of that pentagon peach. Okay, so we got that our whole box was 8 times 13, so 104. And then I found the area of each of my 5 triangles, and I added those together and subtracted it from 104 and got that the area of that pentagon is 60 units squared. So if you have any questions, make sure you write them down so you remember to ask me in class tomorrow. Werner out.